Welcome to Pumping Python. My name is Jacob Itegboje, and this is the Truth Table with Binary Operations Part 2. Time to write some code. I will open the terminal, then add def test underscore negate underscore first, parentheses self colon at the end. Self.assert false, parentheses source.truth underscore table dot negate underscore first, parentheses true, comma true. The terminal shows attribute error. Module source.truth underscore table has an attribute negate first. Def negate underscore first, parentheses p comma q colon at the end, return false. The test passes. Self.assert false, parentheses source.truth underscore table dot negate underscore first, parentheses true comma false. The test is still green. Self.assert true, parentheses source.truth underscore table dot negate underscore first, parentheses false comma true. The terminal shows assertion error. False is not true. If p is equal to false and q is equal to true, colon, return true. The test passes. Self.assert true, parentheses source.truth underscore table dot negate underscore first, parentheses false comma false. The terminal shows assertion error. False is not true. If p is equal to false and q is equal to false, colon, return true. The test passes. The two cases where this function returns true are both when p is false, which means I could just write if p is equal to false, colon, return true. The test is still green. I will remove the other if statements. I know from earlier that I could change this first statement to if not bool parentheses p colon, comment the next line out. The test is still green. I'll remove the commented line. I can also change this line to if not p colon, comment the next line out. The test is still green. I'll remove the commented line. And now I can write return true if not p, else false. The test is still green. I'll remove the other statements. I can also write return not p, which is simpler. Still green. I will remove the other statement. Def test underscore logical underscore NAND, parentheses self colon at the end. self.assert false, parentheses, source.truth underscore table dot logical underscore NAND, parentheses, true, comma, true. The terminal shows attribute error. DEF logical underscore NAND, parentheses, P, comma, Q, colon, return false. The test passes. Self.assert true, parentheses, source.truth underscore table dot logical underscore NAND, parentheses, true, comma, false. The terminal shows assertion error. False is not true. Using what I know so far, I will add if P and not Q, colon, return true. The test passes. Self.assert true, parentheses, source.truth underscore table dot logical underscore NAND, parentheses, false, comma, true. The terminal shows assertion error. False is not true. If not P and Q, colon, return true. The test passes. Self.assert true, parentheses, source.truth underscore table dot logical underscore NAND, parentheses, false, comma, false. The terminal shows assertion error. False is not true. If not P and not Q, colon, return true. The test passes. There's only one case where this function returns false. I will add an if statement for it with an else clause. If P and Q, colon, return false, else, colon, return true. The test is still green. I'll remove the other statements. To use one return statement to represent all of this, I need an if statement that returns true, but I only have the else clause. So enter here if not parentheses P and Q, colon, at the end, comment the else out. The test is still green. I'll remove the else. Now I can simply return not parentheses P and Q. The test is still green. It is worth noting that when I have an if statement that returns false with an else clause, I could just return the logical negation of the condition in the if statement. Remove the other statements. DEF, test underscore tautology, parentheses self, colon at the end. Self.assert true, parentheses, source.truth underscore table dot tautology, parentheses, true, comma, true. The terminal shows attribute error. DEF tautology. Parentheses P, Q, colon at the end. Return true. The test passes. Self.assert true, parentheses, source.truth underscore table dot tautology, parentheses, true, false. The test is still green. Self.assert true, parentheses, source.truth underscore table dot tautology, parentheses, false, true. The test is still green. Self.assert true, parentheses, source.truth underscore table dot tautology, parentheses, false, false. The test is still green. Tautology always returns true. DEF test underscore logical underscore disjunction, parentheses, self, colon at the end. Self.assert true, parentheses, source.truth underscore table dot logical underscore disjunction, parentheses, true, true. The terminal shows attribute error. DEF logical underscore disjunction, parentheses, P, Q, colon, return true. The test passes. Self.assert true, parentheses, source.truth underscore table dot logical underscore disjunction, parentheses, true, false. The test is still green. Self.assert true, parentheses, source.truth underscore table dot logical underscore disjunction, parentheses, false, true. The test is still green. Self.assert false, parentheses, source.truth underscore table dot logical underscore disjunction, parentheses, false, false. The terminal shows assertion error. True is not false. Add if not P and not Q colon, return false. The test passes. I know from logical NAND that I could do return not parentheses, not P, and not Q. The test is still green. I'll remove the other statement. Now not happens 3 times on this line. I'm going to try to multiply it by everything in the parentheses to see if I can make it simpler. Return not P, not and, not Q. The terminal shows syntax error, invalid syntax for the not and with the red squiggly lines under it. Hashtag syntax error in the list of exceptions encountered. Then change not and to or. The test is green again. I'll remove the other statement. I can also remove not because that cancels out. Two nots make a right. All right, binary operations take two inputs. Each one of them could be true or false, which leads to four cases. If the first input is named P and the second one is Q, logical disjunction returns P or Q. Tautology always returns true. Logical NAND returns not parentheses P and Q. Negate first always returns not P. Converse non-implication returns not P and Q. Project second always returns Q. Logical conjunction returns P and Q. Contradiction always returns false. Would you like to test more binary operations? I'll see you in the next one.